was not long after the first aircraft took flight that the idea of dropping bombs from it came about. It was less than 8 years after the Wright Flyer that an Italian pilot dropped 4 small hand grenades out of his aircraft onto the enemy. 2 years later, in 1913, anti-aircraft guns were developed by the French and the Germans to defend against this new threat from the air. As with all military technology over the history of humanity, the pendulum swung back and forth between the aggressor and the defender. High-altitude bombing with extremely accurate bomb sights to allow the bomber to fly above and out of reach of the anti-aircraft artillery. Next came anti-aircraft missiles, or SAM for surface-to-air missile, that can reach higher altitudes and significantly longer ranges. 3 distinct technologies emerged to combat these missiles. First, standoff range weapons. These are weapons, like cruise missiles for example, that allow the attacker to launch their weapons outside of the range of the surface-to-air missile, therefore keeping it safe. Second, electronic warfare, specifically jamming. I just made a video on this topic, but it's using radio waves to confuse an enemy SAM system, so that it cannot lock onto you and shoot at you. And third, anti-radiation weapons. These are weapons designed to home in on specific radar signals. These weapons are fired at the radars of the surface-to-air missile site and destroy them so that they cannot fire at you. All 3 of these technologies fit into a category called SEAD, which stands for the Suppression of Enemy Air Defense. There is a related action called DEED, Destruction of Enemy Air Defense. This is actually destroying not only the radar which guide the surface-to-air missiles, but destroying all the launchers and even the infrastructure as well. SEAD does not require that though. In fact, SEAD does not even necessarily require that you destroy the radars which guide the missile. Any method used to suppress the site so that it cannot fire on you is included. The reason SEAD is important is because air superiority is important. In today's world, it is virtually impossible to win a war without having air superiority. And to establish air superiority, you need to eliminate your enemy's ability to defend themselves from attack from the air. That includes fighter aircraft, but also ground-based air defense sites. The idea of attacking air defense sites is nothing new. It was done during World War II. The concept of SEAD itself really becoming its own tactic came about during the Vietnam War. The S-75, better known in the West by its NATO name, SA-2, was the air defense system that was most heavily used, and posed the biggest threat to US and Allied aircraft. The S-75 was an incredible weapon for its time. It was responsible for shooting down the U-2 spy plane flown by Francis Gary Powers over the Soviet Union in 1960. It has an operational range of over 40 kilometers and can reach altitudes of up to 25,000 meters, much higher than any operational bomber aircraft. The system became extremely popular in the Soviet sphere and is even still used to this day. But back to Vietnam. Vietnam received nearly 100 S-75 systems during the war. It is estimated that the system is responsible for shooting down around 1,000 US aircraft. The US needed a way to counter this threat. One method was to employ radar jamming. The goal is to confuse the radar, which guides the missile, so that it could not fire. The second method was directly dealing with these sites and radars by employing anti-radiation missiles. Enter the Wild Weasel. Wild Weasel is a codename given to aircraft carrying out SEAD missions. 2 weapons were developed for these aircraft to utilize during the Vietnam War. First, the AGM-45 Shrike, and a few years later, the more intelligent AGM-78 Standard. Both were anti-radiation missiles, meaning that they home in on radio emissions. The frequency to listen in on was that of the radar of the S-75, where it would fly to and detonate, destroying the radar. One method used by the crews of the S-75 units was to turn off their radars when the Wild Weasels were spotted. That way, these missiles had no radar emissions to lock onto. And this can fast forward us to today. While turning off the radar so that these weapons cannot attack your site may seem like a victory, it is just the opposite. By turning off the radar, the SEAD mission has been, in essence, accomplished. It suppressed the air defense site. When the radar is not on, it cannot detect the aircraft and fire at them. This tactic does, however, allow the SAM site to survive and fight another day. The SAM site operator who decided to leave his radar on and fight was quickly put out of commission by one of these anti-radiation missiles, or ARM for short. Modern ARM weapons are smart. They can store in memory the location the site last had its radar turned on. So not only did these SAM sites have to turn off their radars, they had to move. It is no surprise that every single air defense system produced later on by the Soviet Union and later Russia is mobile. Even long-range systems, which historically required fixed sites, are able to pack up and be on the move in less than an hour. While mapping Syrian air defense sites for our project of marking locations of military sites throughout the world, I first ignored the sites that were seemingly abandoned. Only recently did I go back and mark these sites, as air defense systems move around all the time to avoid being targeted. So, with the basics of SEAD and a brief history covered, we can move on to the tactics that are used. As I stated, there are three main technologies utilized: jamming, anti-radiation missiles, and standoff weapons. Standoff weapons are interesting as they are not often thought of while discussing SEAD. This is a broad category and can include many different types of weapons. Things like long-range glide bombs like the SDB and JSOW are one. SDB is interesting as it is a small, inexpensive bomb, so many of them can be carried by each aircraft, and fire a lot of them against a SAM site. If the enemy does detect and engage them, they will have to launch many of their valuable missiles to destroy each one. This is a simple and relatively inexpensive way of attacking an air defense site, by overwhelming it with targets to shoot at. Another weapon is cruise missiles. Cruise missiles like the Russian KH-55, its derivatives, and the KH-59, and the US JASSM or even Tomahawk can be used. These weapons all fly extremely low to the ground to avoid detection by radar, so that they can, in a sense, sneak up on their targets. One issue with standoff weapons is that you need to know where to fire them. Unlike armed weapons that can home in on radar emissions, standoff weapons typically fly to a preset location. So when utilizing them against SAM sites, which as mentioned before, often move around, having up-to-date intelligence is important. Things like satellite imagery, which has seen a major leap in technology and turnaround time, can help identify the location of these sites. Websites like Planet can provide relatively high-quality imagery of nearly every site on Earth every single day. And that is just what is available to the private sector. Other intelligence gathering platforms could include recon aircraft and UAVs, like Global Hawk. Anti-radiation missiles, or more simply referred to as ARMS, are the most well-known SEAD weapon. They home in on radar signals and destroy it. These have an extra benefit, as the missiles themselves do not emit any radar signal, so that the air defense site does not have any extra indication letting them know that they are coming. As it homes in on radio signals, it can attack other forms of sites, like enemy facilities broadcasting radio communications. The US currently only uses one, called the AGM-88 HARM. It is a very advanced weapon, designed with decades of experience built off the top of extensive knowledge gained by the US military during Vietnam, and has also been upgraded several times since, after experience from both wars with Iraq, Operation El Dorado Canyon against Libya, and others. Its stated range is to be around 150 kilometers, but that will vary greatly depending on the altitude and the speed the missile is fired from, as that is the nature of arms. Their engines only burn for the first part of the flight, then they shut off and glide to the target. For this reason, arms are typically lofted high into the air to maximize their range. Russia currently has a few different armed weapons in its inventory. First, the longer range KH-58. It's a big missile, with a range varying depending on version, but up to 250 kilometers maximum. It's an older missile which is going to be replaced by the KH-31. The KH-31 was originally, and some variants still are, anti-ship missiles. The KH-31P is the anti-radiation version. Again, ranges vary, but they are stated to be between 100 and 200 kilometers. And finally, the shorter ranged arm, the KH-25. The KH-25 is a large family of air-to-surface missiles. The KH-25MP and the upgraded MPU are the versions with the anti-radiation guidance method. It's a smaller missile with a shorter range, about 60 kilometers. One issue with arms is that, in order for them to work, the enemy must have their radar turned on. During war, air defense sites will typically try to keep them turned off to keep themselves hidden, and rely on other methods, such as other early warning radar stations to alert them when there are targets in the area. So the challenge for the SEAD mission is to get the air defense sites to turn on their radars. One method of doing this is to utilize decoys. These are small, unmanned aerial vehicles which mimic the appearance of manned aircraft on radar, like fighters or bombers. Using decoys have two benefits. First, the enemy air defense site will turn on their radars to engage them, allowing the SEAD aircraft to locate and attack the sites. And the air defense site will have to expend missiles shooting at the decoys. Every missile fired at the decoy is one less that they can fire at you. The third technology mentioned, jamming, or ECM, electronic countermeasures. I won't bother going into much detail, as I just finished an 18-minute video on this topic, but it's basically using different methods to confuse the enemy radar or communications so that they cannot shoot at your aircraft. And these three methods are not mutually exclusive. Combination of any two, or even all three may, and often are, employed at the same time to accomplish the SEAD mission. And finally, the most simplistic, non-technological method is just avoiding the SAM sites altogether. If you know their location, you can avoid them, fly around them. However, if you are on a bombing run, odds are that you are attacking a site that is important. And the enemy thinks these things through. Oftentimes, important sites are guarded by SAM systems to defend them, so avoiding them is not always an option. Another option that has been utilized since Vietnam is to fly extremely low to the ground, hiding yourself from the enemy's sight and radar behind terrain. Mountains, hills, valleys, even trees. Many older SAM systems were not able to engage these low-flying aircraft. However, newer systems have been developed to do just that. Also, with Russian systems, radars are often mounted up high in the air, so that they can see above things like trees and engage the incoming aircraft or missile. And that brings us to the defender's side of this equation. Methods have been devised to counter all of these tactics employed to conduct SEAD. Newer systems are capable of detecting and engaging low-flying aircraft and missiles. Some SAM systems, like the Russian Tor and Panther, are designed to be able to very quickly respond and shoot down cruise missiles that are hidden behind terrain until the last possible moment. Newer radars are able to change frequencies, which counter radar jamming. And SAM systems like the S-400 and Patriot are able to engage at long ranges very small targets, like anti-radiation missiles. The Patriot SAM system is a pretty advanced system in terms of technology and computer processing. Most of the work is automated, making the operator's job much easier, basically to the point where all they have to do is to decide whether or not to fire. The system can automatically classify targets, like TBMs, tactical ballistic missiles, ABTs, air-breathing targets like aircraft and cruise missiles, etc. Arms can be identified by the Patriot based on their distinct flight characteristics. That is, identifying a potential arm-carrying aircraft, the launch, the ascent, turn down, and terminal phases. Once identified, Patriot offers the operator a few different options to defend itself. It can switch the radar to operate in low power mode. This makes it more difficult for the arm to lock onto the radar. It can reduce its search area to reduce the number of pulses available to the arm. It can change frequencies, again making it more difficult for the arm to find the radar site. Or it can engage the arm by firing a SAM to shoot it down. Another method is using SAM systems that do not rely on radar for guidance. This makes detecting them much more difficult, as they are not emitting any radar signals, and makes anti-radiation missiles useless. Some Russian SAM systems use, in addition to radar, visual guidance by electro-optical guidance. Certain variants of the Cub, Buck, and Panther can use this form of guidance, so that it does not alert the target that it is about to attack. Infrared guidance is another method, commonly used in shorter range systems, like manpads. Both of these forms of guidance are considered to be passive guidance, as they do not emit any signal to alert the target to your attack. This is compared to active guidance, like radar, which is actively sending out signals that can alert your target as to your intentions. These, however, suffer from a few shortcomings. Clouds, smoke, and even atmospheric distortion limit the range of this form of guidance. And last, but certainly not least, is having an integrated air defense system, or IADS. This has been proven to be the utmost importance when defending against an enemy, especially against SEAD. Instead of having each SAM site on its own to detect and shoot at targets, an integrated air defense system puts all SAM sites, radars, and air bases hosting interceptor aircraft under one command. This way, each unit can coordinate and share information. This allows a SAM site to receive information about an aircraft or missile that was detected by another radar. That radar may be over 100 kilometers away, but with this information, a long-range SAM could engage it, allowing it to not have to turn on its own radar, which would give away its position, until the last possible moment. IADs make it much more difficult to conduct SEAD. Instead of fighting against a single air defense site or radar, you are now fighting an entire interconnected web of sites, radars, and air bases. Integrated air defense systems also benefit from being able to help counter jamming. Multiple radars can be used to pinpoint the location of a jamming aircraft, so that it can be engaged. Virtually all large, modern militaries have some form of IADS operational. Russia, China, the US, along with many others. Having an integrated air defense system alone will not save you though, as seen with Iraq and Libya and in other conflicts. Russia, for example, creates a bastion of overlapping SAM sites with redundant command and control nodes, combined with a multi-layer defense consisting of long, medium, and short-range air defenses, along with interceptor aircraft to quickly respond to any threat. This makes the SEAD mission infinitely more complex and difficult. And that is basically where we are today. The duel between advanced aircraft, armed with high-tech anti-radiation missiles, jamming equipment, and standoff weapons, and the IADS, with its interconnected system of SAM sites and radars. But if history has taught us anything, the pendulum will continue to swing, back and forth, with the advantage switching from the aggressor to the defender, and back again.